It represents NASA's earliest efforts to send humans into space. These Redstone rockets were formerly ballistic missiles provided to NASA by the U.S. Army. In October of 1958, NASA formally organized Project Mercury with a mission to investigate man's reaction to this new environment and safely recover the capsule and its pilot. Man rating for human spaceflight on what was previously a ballistic missile was no easy task. After several modifications and test flights, a Mercury capsule carrying Ham, a chimpanzee, was successfully launched and recovered on January 31st, 1961. Just months later, on May 5th, astronaut Alan Shepard launched on a Mercury Redstone rocket, becoming the first American in space.
Billion ping pong balls to fill it. It was built in the 1960s for the Apollo program. Every Saturn V rocket that sent humans to the moon was assembled right here. Every space shuttle mission also assembled within these same walls. After the space shuttle program, a major renovation to the inside of this building.
Well, those were the hangars for the space shuttle. Now, as we turn the corner, you notice the large, actually open.
Directors and their teams oversee every rocket that lifts off from KSC and give the final go or no-go. I'm inside the LCC with Charlie Blackwell-Thompson, NASA's first female launch director. Now, Charlie, can you tell us a little bit more about what a launch director does?
Absolutely. The launch director's job during the planning phase is to ensure that you have everything in place that you need to safely and successfully launch the Artemis missions. That includes things like your requirements are set, your launch commit criteria are understood, your procedures are ready to go, and your team is trained.
Watch the moon display located near the Lunar Theater. At the Lunar Theater, located at the nose end of the Saturn V rocket, you can relive the experience of Neil Armstrong's historic landing and first steps on the moon.
All right.
Is that you?
Oh, yep, that's me.
Thank you. Want me to put it in my pocket?
No, I got it. I'll put them up. I know. I guess here.
As you enter, please move all the way to the front of the theater to make room for the guests behind you. Our presentation will begin shortly.
I think this is the front.
Oh, maybe.
Launch control for the Apollo mission. This is not a mock-up. These are the very consoles we sat at when men first took off to fly to the moon. The tragedy of Apollo 1 had put us a year and a half behind. We were making up for it in one big leap, and we were doing it with a rocket that no man had ever flown before. It was a few days before Christmas 1968 when Apollo 8 sat on the pad. She was the first of a new kind, a moon rocket. This was the Phoenix, risen from the ashes of Apollo 1. The first Apollo crew did not die in vain. This was to be their testament. "36 stories high, she had been fully fueled throughout the night. The liquid oxygen in her tanks caused ice to form on the outside of the crater. The extreme temperature differences between the air and the sub-zero fuel caused the metal skin of the rocket to expand and contract. Everyone was on the pad agreed. It was as though the rocket was alive, breathing, straining in reach. Earlier in the morning, astronauts Frank Borman, Jim Lovell, and Bill Anders had made their final preparations before taking that long ride out to the waiting spacecraft. The minimum safe distance from Saturn V at liftoff was 3 miles. The reason was simple. When fully fueled, the rocket contained the explosive power of an atomic bomb. As the clock counted down, the astronauts and all of us in launch control went through the preflight checks, our hands on the controls of the most powerful, most complex machine ever built. It had over 2 million separate systems, and to bring these men back alive, everything had to work perfectly. Each individual system had been tested, but what we didn't know was how they would perform when all 2 million began to work together. That moment would come when the countdown clock reached 0. If a maneuvering thruster failed, if communications broke down, if navigation was off by 1 degree, if any piece of the miles of wiring, circuits, relays, or valves was defective, Frank Borman, Jim Lovell, and Bill Anders would pay with their lives. As they sat, waiting for launch on that chill December morning, these 3 astronauts were back to what they had always been, test pilots. You are now in the final minutes before the launch of Apollo 8, right here where it actually happened. Mankind is about to leave his planet behind and journey to another. It is one of those rare moments when history is not being made, destiny is being embraced.
This is launch control, T-minus 3 minutes and counting. We've completed our communications checks with the Apollo 8 astronauts in the cabin, and the communications are go. During this period, once we do get the firing command, the various tanks within the 3 stages of the Saturn V launch vehicle begin to pressurize. We have firing command. Firing command is in, and now on the right sequence, 2 minutes, 20 seconds. Our status code indicates that all aspects are ready, instrument unit is ready, spacecraft ready, final check of the emergency detection system, that relay light also on. First stage preparations are completed. Final reports coming from Borman at this time. Look at the switches aboard the spacecraft. 20 seconds, all aspects we are standing at this time. Realize 15, 14, 12, 11, 10, 9,
Apollo 8 successfully orbited the moon, and the astronauts returned safely to the Earth. I know. I'm Jim Lovell, and I was one of the crew of this spacecraft, Apollo 8. We were the first men to see the surface of the moon from just a few miles away. But it was the hundreds of thousands of men and women who worked in that team, and the millions of people who supported the mission that really made it possible. That way, I guess, we all went to the moon. Now, on the other side of those doors, you'll find an actual Saturn V moon rocket. It's still the most powerful, the most complex machine ever built. And I guess it's the only one that can take you to another planet. I actually got to fly on a second flight to the moon called Apollo 13. But that's another story.
There's the restroom. Probably should. Need a red light? Okay. I'm recording. Actually, yeah, we'll walk it, but I want to come back. I want to look in there. You can go outside. Oh, look. It's a separation. That's where it separates.
The center of gravity of the lunar module was not in the lunar module. It was way out in the field someplace because we had attached to the lunar module a 60,000-pound jet back. That meant that when I wanted to go right and use the controller to go right, I had to witness a wild gyration.
This is the command
Actually,
module.
had to learn how to do.
It's attached to the command module. That's the command module.
Hi, I'm Jim. Apollo 8 was changed from its original mission. Its original mission was to take a lunar module up into Earth orbit and then test the lunar module for a series of days to make sure it was ready to go to the moon. But lunar modules were not ready for the time of Apollo 8. So the mission was changed. We heard that the Russians were going to put a man around the moon in the late fall of 1968. And so we thought, we can do that too. And so therefore we started to work hard. I became the navigator of Apollo 8, went to MIT to study the navigation, and then on December 21st, with all set to go, we launched on the first flight to the moon. And actually, we did beat the Russians to the moon in December of 1968 and saw the far side of the moon for the first time, because as you know, we never see the far side from the Earth. Hi, I'm Jim Lovell, retired old astronaut. I did 4 space flights back in the 60s and 70s. And if you
I want to see if it touched the moon or not. Touch the moon. Look at this one. I guess that's for
What do you want? Funny. What? You have to see whatever is the number of pages and then after it goes through its whole
wow.
Certainly loves a ball here today. Hope that continues.
May I have your attention, please? Should you need to leave the presentation for any reason, we ask that you exit using the doors located at the front of the vehicle. And as a reminder, please refrain from cell phones, video recorders, or external lighting. Thank you.
really don't want me to take a nap. So they don't want me to take
Sorry. I was oblivious. Let me get a picture. You want a picture with your phone?
Unbelievable. I had no idea what it was. Terrified, exhilarated, and my reaction actually surprised me. I walked over and it was such an unbelievable feeling. It was so close.
How do you get to the second floor? How do you get to the second floor?
Solar energy, we do something better with gliders. We fly what's called a fitting alignment circle, or a curved vision, like a spiral. The speed and the glide angle are excessive at this point in the approach. You actually began to fly a shuttle. It's very different, and it's not until after around the many hours of training to get you safely on the launch.
Range 20 nautical miles.
Works pretty fast. You can go if you want. It's okay.
Touchdown. Everyone's geared to send Go.
Pattern. And just for reference, that's one sleep station. This one's another. There's one on the ceiling, if you want to call it. And then there's a fourth on the other wall. So all of us sleep in a little bit of a circle.
Oh yeah, that's the tube.
She's got a screw in this one.
So this is that sleep chamber shoes. Huh. That's crazy. There's a Walkman. Hey, this is the Aurora Borealis.
What about, can you read this thing? There's just...
And my past is just disappearing behind you. The world is small, it's incredibly fast. I mean, you go through the sound of 3 seconds straight out, 2 minutes higher and faster. And so you're just riding this ride. And at the end of this, and they're empty. They're out. Thank you.
You kind of look back and then forward and you hit 0 and the solid's like, poof, you're going. We have never look out the window, so we just kind of look at each other. And here we go.
Well, it all happens so quickly out there. You're talking about a 6-second period of time in which the 3 engines lights come up to speed, and you can certainly feel them.
For speed, you are really going to love this simulation. It's going to be a great experience, and you're going to really feel like you're going somewhere fast.
I hope you have a lot of insurance.
Hi, welcome to the Shuttle Launch Simulation Facility. I'm Charlie Bolden. I've flown the shuttle into space 4 times, twice as a commander. My colleagues have put together an interesting little experience for you today. You're about to go on a high-fidelity launch simulation, and I am going to help you get through it. See, before any launch, all astronauts have spent thousands of hours being tested and trained in simulators, a lot like the one you're going to ride. You'll be riding on a special module that fits right into the payload bay. But before you go aboard, we'd better go over a few basics. Launch preparation for your mission would have started accelerating here at KSC months in advance. But let's cut through all that and move you way closer to launch. I'll start your clock at, say, 4 hours before liftoff, when it's still dark out. Before you got suited up, the shuttle's external tanker ET was fueled up. The ET holds fuel for the shuttle's 3 main engines. Inside the ET, there are actually 2 separate tanks. One has liquid hydrogen at 423 degrees below zero, the other liquid oxygen at 298 degrees below zero. They start really cold. But when those 2 liquids meet in the shuttle engines, you'll find out. About 2 hours before you launch, you boarded the orbiter through what we call the white room. As you climb through the hatch, that orbiter already seemed like it was a living, breathing thing. Then they pulled back the access arm and left. Everybody else is smart enough to get out of the area fast, and you and your crewmates are strapped to the reason why. Within 400 feet of the pad, the flames and heat from the engines will kill you. Within 800 feet, the sound will kill you. Within 4,000 feet, the snakes and alligators might kill you, because all that low-frequency vibration really stirs them up. But I'm getting ahead of myself. Let's back it up to T-minus 10 seconds. Those sparks are hydrogen preburners, or sparklers. They help prevent a fire or explosion by burning off any excess fuel around your vehicle. At T-minus 6.6 seconds, the main engine will ignite. You'll hear a loud roar, and you'll feel a big rumble. After the main engines start, you'll feel the shuttle sway forward a little, but don't worry. It's engineered to come back to vertical before you go. That's what we call the twang. You're getting a lot of power from those main engines, but you're going to need even more to get to orbit. That's where the solid rocket boosters, or SRBs, come in. These guys were the most powerful solid fuel rocket engines ever flown. The SRBs ignite when the countdown gets to 0, and believe me, you'll know it. Once you fire the SRBs, you can't turn them off, so you're going somewhere. You better just hold this up. Now, here's how all that's going to happen to you in real time. 10 seconds will remain in start. 7, 6, 5, 4, 3, 2, 1, and forces reach a critical level we call max Q. Here, the forward thrust of the rockets is fighting the resistance of the air, and the shuttle is like an aluminum can being squeezed harder and harder. To make sure this doesn't happen, we throttle down the engines to maintain pressures we engineered the shuttle to withstand. Once you pass through max Q, we throttle the engines back up. It was at this moment that we lost the Challenger in 1986. So this is always a thoughtful moment in any mission. About 2 minutes into your flight, all the fuel is spent in your SRBs. So you jettison them and they'll parachute down into the ocean. These guys were designed to get cleaned, refurbished, and then used again on another mission. Your ride will get a little less bumpy once your SRBs drop off, but you're still going to keep accelerating, so that's when you feel those G-forces really hit you. A few moments later, your ET will have spent all its fuel, and you'll be go for main engine cutoff, or MECA. Then you'll jettison the tank. We call that ET-7. The tank will break up in the atmosphere on the way back down. It's the only part of the shuttle system that wasn't designed for reuse. Congratulations, you made it into orbit. That's assuming, of course, there were no malfunctions along the way. Naturally, we have hundreds of contingency plans in case something does go wrong. Take a moment to memorize these now. Got it all? Good. Our time here is up. You ready? Because now you have to take your chances in the sim and hope the sim supervisor goes easy on you. Now it's time for you to experience the sensations of launch firsthand from inside the shuttle. See you aboard.
I don't know.
Roger that, Miner. Houston now controlling the flight of the miners. 24 seconds on the flight. All programs complete. The miners now heads down, wings level on the proper alignment for a 6.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station.
Normally, the astronauts would have to wait like that for a couple of hours, so just sit tight. I'll be back. Just kidding. Now, remember, at 6.6 seconds, your main engines will ignite. Then the shuttle will twang. Then the SRBs are going to light, and you are off. Remember that 10 p.m.? You made it to max Q. Your main engine is brought back up to 100%. Fuel is spent in the solid rocket boosters, but you're going to jettison them in 3, 2, 1. That means if something goes wrong now, you don't have enough fuel to abort back to the launch site at the Kennedy Space Center. Fortunately, everything's done, at least for now. Guess I spoke too soon. See? That's what it's like in a training simulation. The diabolical sim soup and your trainers are always throwing emergencies at you. Let's see how the crew does.
Instead, it looks like we have a cabin leak. Roger, we see a negative DPDT. We're going to cabin pressure leak procedure.
Negative DPDT means that you're losing air pressure. A cabin leak is never a good thing. Your flight deck crew is working on the problem now. Ever been to Zaragoza, Spain before? Well, if they can't fix it, we'll be landing there in a few minutes.
We close the cabin relief isolate valves. Roger, looks like that's all the problem. Press the meter.
The crew isolated the leak. Nice job. Looks like you're still on track. You're now pulling 3 Gs. You don't want to go over 3 Gs, so you're going to throttle back a little and get ready for main engine cutoff.
3 back to 72%.
You're now going 23 times the speed of sound, or just over 17,000 miles per hour. When you hit 17,500, get ready for main engine cutoff in 5, 4, 3, 2, 1. Wave goodbye to the external tank and say hello to outer space. On this adventure today. Now, whenever you see a space launch, hopefully you'll remember your experience here today. And at least in spirit, you'll be on board. And who knows? Maybe one day you will fly with us.
There was
Yeah, there's some trash cans. You sure you don't want any of this? Oh, that must be it.
Yep.
May I have your attention, please? Flight 2253, service to Venus, will be departing immediately.
Must not do anything.
They won't let us have drinks in the drink place. I know, I thought that's what I thought. Bye.
Hi, Bob.
Hi.
See you on the shuttle, too.
to imagine constellations more than just as they are. But did you know, like us, stars are born and die? Star life cycles are responsible for some of the most stunning sights in our universe. And today we will traverse thousands of light years to see them firsthand. LD, the end is go.
Oh, they stay there.
Webb telescope in just a moment, launched back in 2021. Webb's increased resolution, 100 times more powerful than the Hubble Space Telescope, was a marked step forward in our study of stars. Before we could fly there ourselves, telescopes like Webb allowed us to observe stars inside nebula like our first destination, located 1,500 light years away in the constellation Orion. Horsehead Nebula, first discovered in 1888. The distinctive dark horsehead shape of the nebula is a cloud of dust that blocks the light of the glowing nebula behind it. Dusty nebula clouds like this one are often called stellar nurseries because they're where new stars are born. There's one now, a protostar, the first step in a star's life cycle. Once a protostar reaches a stable state, it becomes a main sequence star and will continue in that phase for millions to tens of billions of years. So we've seen a star's birth. Now let's take a look at a dying star. Discovered in 1731 and most famously photographed by Hubble in 1999. We're so far away from Earth, the light we're seeing now won't reach home until after the year 8,500. When a star about 8 times as massive as our sun dies, it goes out with a bang in a violent explosion called a supernova. And these beautiful celestial clouds are what's left behind. Saved something special for last. A Wolf Riot star. A rare and beautiful type of star nearing the end of its life cycle and about to go supernova. At 1,000,000 times brighter than our sun, this star emits stellar wind approaching 100,000 miles per hour. Its ejection shell is so large, our entire solar system could fit across it end to end over 2,000 times. When Wolf Riot stars explode in a supernova, they see the universe with the heavy elements that make up planets, stars, and even our own bodies. From the fiery crucible of this star's death come the building blocks of future worlds. But now, we make the 28,000 light-year journey back to one of the most beautiful sights of all. Earth basks in the glow of our own star, the sun. It's the energy source that sustains nearly all life on our planet.
Fiat Mission Control. Welcome back. Your approach is free for highway traffic. Cleared for landing on runway 31. Fiat copy.
Transported back to the gate shortly. It's been a pleasure having you all on board today for this journey to the stars. We thought we'd back up ground, but thanks to generations of space telescopes, the wonders
Ensure you collect all your personal items from the compartment behind
She has
you.
to unlock it.
Through the open door to
Oh, okay. She has
Thank you for flying.